Part 2 of lesson 40, we're going to continue with our first example. It's from Engage New York's topic, obstacles removed, surprising result. So this is just some of the work we did beforehand and some of the vocabulary. We've already talked about real solutions, functions, cubic polynomials, end behavior, infinity. We talked about solutions. We started talking about remainder theorem, and now we're at factoring and linear factors. So those are all the vocabulary we've already used. And let's go back to part E, F. Okay, we took a polynomial function and we discovered that x minus 1 is a factor of the polynomial, and so now we need to factor out x minus 1. If you're wondering where I got x minus 1, please see the previous video from this polynomial. And I attempted long division, and I did it with a few mistakes, but now I'm going to use box method and reverse box method to divide. So my first term goes up here. My last term goes down here. There shouldn't be a remainder, right? Because we used remainder theorem and we found that there's no remainder. So I can put this -5 here. Now, from here, I'm going to factor out x squared. And I think to myself, x squared times -1. I'm going to fill this part out. So if you like to use box method more, then you're using box method right now. And you're just doing this with me. All right. Lovely. I left the answer from the previous video so we can check our work. X squared plus 4x plus 5. Now, I think there's 2 more parts to this example. So let's finish this. I'm going to rewrite what I wrote before. X minus 1, x squared plus 4x plus 5. Woo! Okay. What are all the solutions to this polynomial function? We already said one of the solutions was x is equal to 1. And you're wondering why I always have you decide if it is a factor or a solution, and why I'm so picky. It's because it comes in handy right now. This video and the last video, we're just combining a lot of our Algebra 2 skills. Okay, this is a solution. X is equal to something. X minus 1 is a factor. What are all the solutions? What does that mean? That means we have to find the solutions here. Let me tell you something. You're not going to be able to factor it very easily. You're going to need to find x, find all the solutions, find x, using our very favorite quadratic formula. X equals -b plus or minus the square root b squared minus 4ac all over 2a. And because it's a video and you're watching this at home, you can finally sing along with me, because I know some of you have been not singing along with me in class because you're embarrassed. So sing it out loud at home. All right. Let's take x squared plus 4x plus 5 and apply the quadratic formula. X is equal to -4 plus or minus the square root 4 squared minus 4ac all over 2 times 1. Okay, this is going to be quite a long process to simplify. So during this time, annotate which parts are going to confuse you, or which parts you know you've messed up on before. And then once you annotate it, you're less likely to make that mistake in the future. And if you make a mistake, just fix it. If you make a mistake and you find yourself erasing, go ahead and document why you erased it. Oh, I missed a negative. I always do that. Write that down. 16 minus 20 over 2. X is equal to, I am going to break this up into 2 fractions right now. 4 over 2 plus or minus, this is a 20, -4 over 2. I subtracted 16 minus 20. Now, I broke up the big fraction into 2 fractions because I just find it more manageable when I do that. So, because now look, I can simplify this part. -4 over 2 is just -2. Plus or minus, I'm going to break this up to positive 4 times the square root of -1 over 2. X is equal to -2 plus or minus. Now 4 is a perfect square. 2, the square root of -1 is I. Here we go. X is equal to -2 plus or minus, I can simplify this, I. All right, back to our table. Okay, actually, yeah, we have our solutions. Now instead of just real solutions, we're going to write all of our solutions. Solutions and factors. So we already said for this expression, x is equal to 1 is a solution, which means the factor is x minus 1. Easy. X is equal to, now I'm going to use our solutions from our previous part, and we have negative 2 plus I. So that means our factor is x minus everything inside here, negative 2 plus I. I'm going to simplify this because this is almost a factor. I'm going to put big parentheses, and I'm going to simplify this to x, and I'm going to distribute my negative sign. Positive 2 minus I. Okay? Be very careful with the negatives. Go slow at this point. This is where a lot of you are going to draw caution signs. Be like, go slow in simplifying your factor. Okay, let's do it again with our last solution. Negative 2 minus I. So now we have x minus, put parentheses around here, negative 2 minus I, and that's going to equal x. I'm going to distribute this negative sign to positive 2, positive I. And I'm going to close out that factor. Oh, beautiful. We have 3 factors here. Factor 1, factor 2, factor 3. So this says linear factors. That means must start with some constant a. It can be 1, 2, 3, negative 1, negative 2, negative 3. It's got to start with a and x to the first power, because linears are when x's are to the power of 1. So all of these have power of 1. So they are indeed linear factors. Now you're going to summarize. A lot of things happened here. Definitely go back and rewind and rewatch and listen to how I talk about each of these problems again. But we need to make this connection, and we started to in previous videos, that this expression, I'm going to write out all the factors. We have x minus 1. We have x minus 2, no, plus 2 minus I, and we have x plus 2 plus I. We have 3 factors here, 3 factors. One factor, another factor, another factor. That's why I always do this when I say factors, because I keep them in parentheses. We also know that this is equal to x cubed plus 3x squared plus x plus 5, or minus 5, minus 5. And this is important because this is the connection I want you to make. You have a degree of 3, and you need 3 solutions. However, before we had always found all 3 solutions because they were all real. Now we're at the point where some of our solutions are not going to be real. And then we're going to talk about what that means in class and what that is called in class. But I want you to make the connection. 3 solutions, power of 3. 2 of these solutions are not real. One of them is. What does that mean for our graph? Let's go back to our graph. 1 real solution, and then 2 not so real solutions. So I want you to think about it, okay? Okay, summarize, ask questions, and we'll continue this conversation in class. Goodbye, everyone.